Welcome everyone to today's webinar, Unlocking the Potential of AI in Transforming Patient Access and Staff Engagement. On behalf of Becker's Healthcare, welcome and thank you for joining us. Before we begin, I'm going to walk through a few quick housekeeping instructions. If you have any questions throughout today's webinar, you can type those into the Q&A box you see on your screen. If at any time you have trouble with the audio or video, please try refreshing your browser. You can also submit any technical questions into the Q&A box. We are here to help. At this time, it is my pleasure to introduce today's presenters. Dr. Muthu Alagappan is the head of solutions at Notable. He has over a decade of experience in building artificial intelligence applications for healthcare, first as a product leader at data science company Ayasti, acquired by the Symphony AI Group, and later as a research collaborator with the MIT Media Lab. And he is a two-time recipient of the Forbes 30 Under 30 distinction. He received his medical degree from Stanford School of Medicine and is a practicing clinician at Harvard's Beth Israel Deaconess Medical Center. We also have Dr. Kevin Huang, who currently heads the machine learning and AI engineering team at Notable, where they develop natural language processing and computer vision models to enable intelligent solutions that automate complex healthcare workflows. Prior to joining Notable, Kevin was the data science technical lead at Change Healthcare, responsible for developing the Claims Lifecycle AI API. He graduated with a PhD in electrical engineering from Stanford University in 2012. Dr. Alagappan and Dr. Huang, thank you so much for joining us today. I will now turn the floor over to you.
Great, thank you so much for that introduction. I am so excited for the conversation today with you, Kevin. And so I want to jump right in. You have many years of experience building AI applications for healthcare. And so I want to start with just some core definitions and conceptual understanding. AI has been in the news so much recently, but probably helpful to start at the beginning. What is artificial intelligence? How would you define that?
Yeah, so that's a great place to start. I mean, there are many ways to think about intelligence, and the way that I think it's maybe the easiest to grasp is that intelligence is a form of information processing. And specifically, we want to process information or data in a useful way. Depending on your objective, useful may be defined in many different ways, but at the core of things, we're taking information, we are transforming it into something we deem more useful or valuable. Now, intelligence can range from low-level tasks like recognizing something in an image or finding a piece of text or a keyword in a text to more complex abilities like logical reasoning and planning. But all that is taking something from the raw state to some more desired state. So it's this ability to transform information into a meaningful manner that's the core of intelligence. And artificial is as the name suggests, is essentially non-biological in origin, and as we know today, only humans have created intelligences, and hence the artificial term.
Yeah, great. I love that. There are a lot of definitions of AI thrown around. I really like that one, and it sounds like you're suggesting AI is non-biologic intelligence, which is to say non-biologic ability to process information in a useful way. The other concept that's often sort of correlated with AI is machine learning. And you often hear people say, AI, ML, almost interchangeably. Are those interchangeable, or is there a difference between AI and machine learning?
Yeah, I mean, these days they are pretty much used, side by side. But strictly speaking, they are different in the sense that AI is the study of making machines intelligent, whereas machine learning is a method that people have used to great effect to achieve that objective. So machine learning is, you can think of that as a subfield of AI, where the focus or the core premise is that we allow the machine or our computers to study the data and digest it to find patterns and distill that information into what we call a model that represents, the world in some manner. So the core information here is that we're allowing the machine to learn the rules and the patterns versus we can think maybe there are other ways where humans can go and code these extensive rules or expert systems up. So that's another way to achieve AI. But in the past 10, 15 years, machine learning is, the best and most effective way people have come across to achieve AI.
Yeah, great. Okay, so it sounds like they could be used interchangeably, but strictly machine learning is a sort of method to perform AI whereby machines can be sort of trained to sort of learn on their own or sort of pick up on trends without having to be explicitly instructed on sort of what to do. So I want to keep going down some of these definitions, as I think this will help us sort of ground the conversation. The other sort of set of concepts that have gotten a lot of attention recently are natural language processing, specifically natural language understanding and generation. Could you help shed some light on what those techniques represent?
Right. So starting from AI, that covers all sorts of data types. So you can look at images, videos, audio, or text. Now for natural language, it's specifically about text and human spoken languages. So natural language understanding is the ability for computers to understand and interpret natural language from users. And some of the capabilities in this domain can include things like sentiment analysis. So you look at a piece of text, understand if somebody's happy, angry, or you can find specific pieces of key information in a body of text, what we call name entity recognition. We can also, use natural language understanding to do intent recognition. So if you say something like, where do I send the check? The computer can understand that you're trying to make a payment. So it's not relying on literal kind of spoken instructions, but it has the ability to infer what you're really trying to do. So that's kind of the big breakthrough in natural language understanding in recent days.
And so, I've heard about natural language processing for, well over a decade in terms of, sentiment analysis and some of these other use cases. So why has it suddenly gotten so much more attention? Can you walk us through some of the recent breakthroughs that have led to maybe a paradigm shift in the way natural language processing is done?
Right. So, in the very early days, certainly people have been doing natural language processing, even 20, 30 years ago. At that time, it's mainly, heuristics based. Maybe you need a lot of linguists on the team to figure out what the exact grammar is, break down the sentences into pieces, then try to put that together into something useful. In the 1990s and kind of early 2000s, there's like a wave of using statistics to learn these patterns from the data itself. So that's kind of the beginnings of machine learning and statistical learning. Now, in that period, it's still due to the lack of data and powerful enough models to represent complex ideas that exist in human language. It sort of worked okay, but really not enough to be used broadly in the real world. The big changes in the past 10, 15 years I see are three-fold. One is the amount of data has exploded due to the availability of that and internet, mobile. A lot of more computing powers available in the cloud. So now you can get clusters of thousands or tens of thousands of GPU processing units. And the models have gotten a lot better. So the models themselves are larger, able to represent much more information. So, those three key pieces combined kind of gave us this wave of really amazing results.
Yeah. So what's an example of something we can do today with these new breakthroughs in data compute and kind of algorithms that we couldn't do maybe 5 or 10 years ago?
Right. So I think the main one is the emergence of what we call the large language models. So in the past, people have had to build very task-specific models. So you have one little model to parse your intent, one little model to maybe extract keywords from what you've said. Now, today with large language models, it's essentially all these capabilities in one, and it performs much better than these niche narrow models. So things that you can do today, the large language model is kind of like both a repository of knowledge. So it has embodied knowledge in it. So you can ask it questions, Q&A style, or you can have it generate information. So you can have it create a list for, maybe fixing your heater. Now, it has more than just knowledge, where you can use its language abilities, such as reading comprehension. You can give it a piece of text and ask it questions. So for example, if you have an insurance coverage that you have, you can ask it, hey, is knee replacement covered under my insurance? And it can read through the text that you give it to give you a reasonable answer. And yeah, there are many places that has been enabled by this technology.
Yeah, that's super exciting, and I think, as you've mentioned, the large language models have introduced a true sort of new paradigm for the types of use cases that can be carried out through AI. But before we get to sort of all of the promise of AI, I want to be a bit critical of maybe the history of AI in healthcare. And so, for the past 15, 20 years, there's been a lot of belief or hope that AI would transform everything in healthcare, from how care was delivered to how it was, how it's diagnosed, to healthcare operations. And I think outside of a few isolated large successes, much of that hype, I think, has, I don't think AI has lived up to the potential that it has been promised over the last 10, 15 years. Do you agree with that assessment? And if so, why has AI fallen short in the past when it comes to healthcare applications?
Mm-hmm. Yeah, certainly there are several periods of AI hype in the past 20, 30 years, as we saw breakthroughs in bots beating people in chess, beating people in answering trivia questions, and also just advancements in machine vision. And we now have technologies like augmented reality and virtual reality. Now, with each of these cycles, there are legitimate technological breakthroughs. And when that happens, it's easy to project how that speed of improvement will result in something transformative. And I think that's where a few of these hypes have come from. This may include, using AI for clinical decision support or for medical diagnosis, even drug discovery with AI. None of them have really caught on in a really broad way to, realize the promises of AI. And I think there is a few issues that, we've learned, obviously in hindsight, that have led to the kind of these promises falling short. So a few of them include, a lot of these systems in the beginning still required a lot of expert coded heuristics or instructions. So in the real world, that will run into issues without being able to keep up with changes in real world complexities. So people kind of lose trust in these systems over time. Now, on the other side, there are like legitimate statistical and machine learning based models that are pretty general. But the issue that those run into is that they're difficult to interpret, and users don't have an intuitive understanding of what these statistics and probabilities mean. So if the machine tells you, hey, someone has a 30% chance of, heart failure, what do you do with that information? Like, I want to know more. Like, how did it come to that decision or recommendation? And a lot of these models are black box in the sense that you cannot inspect them, look inside on what's contributed to the predictions that it has made. So there's a real issue in users interacting with these AI. Now, lastly, there's also just a lack of data in building accurate models. So the performance themselves just aren't there on par with humans, perhaps. So I think those are kind of reasons why we haven't seen AI accomplish more so far.
And I think the big bet most people are making is that generative AI and large language models have really changed the game here, and the performance is a lot better on many of these use cases. And so we've seen, of course, examples of applications trained on large language models or leveraging large language models, outperforming humans in medical licensing and other sort of task-based and performance-based work. Which areas in healthcare do you see large language models most immediately impacting?
Right. With this almost like a step change in the capability of language models, if you look at the past 10, 15 years, this is probably the most important, or one of the most important capabilities that have emerged out of this wave of deep learning in AI. I think if you look at the trajectory of humans interacting with machines through the use of language, you started with Fortran, which was invented by IBM in the 1950s, and structured database query language in the 1970s. All these languages and capabilities allows us to empower machines more, do more of the work, but specifically only for structured data. What do I mean by structured data? That is data that we have specifically curated, formatted into specific forms, and they have discrete attributes. Think of like a nicely formatted spreadsheet. So that is the type of data that we as humans have been able to get computers to process and help us with. Now, the breakthrough with language model or large language models is that it enables us to interact with unstructured data. So unstructured data are things like text, audio, images. Now, obviously, here we're focused on text because we're talking about language models. But now, the world is filled with unstructured text. People's emails, progress notes, lab reports. These are all unstructured data. So the biggest impact that I see today is the ability for people, even non-developers or programmers, to interact with these large collections of unstructured data that has, just an enormous amount of valuable information in there. So that's where I see, being able to use this technology to do better personalization of care, recommendation of care. You can think about doing much better clinical trials recruitment, since that requires going through thousands of patients' clinical notes in order to find the right match. So yeah, everything from clinical trials to reading insurance contracts to determine whether you're in and out of network, or recommendations for diabetes management programs. So that the list goes on. But all this is based on the fact that now we can read, or computers now can read and understand language that we use every day.
Yeah, I love some of those use cases you mentioned, and I remember seeing that 80% of all healthcare data is unstructured. So the vast majority of sort of that latent, untapped data that exists in the EHR is unstructured. And so, as you're mentioning, now that we have the ability to make use of that and to leverage that for use cases, it creates an enormous opportunity. And so I'd love to touch on sort of one aspect of how this, these language models and this unstructured data can be helpful, and that is in personalizing the care experience to patients. You touched on this with some examples, but would love to hear your perspective on where large language models and some of the use of unstructured data can help us better personalize the experience of care for patients. Because for so long, healthcare, despite us having so much data on patients, has felt impersonal. And so hopefully we will see that change, and would love to hear how.
Right. So everything starts with being able to, read through, understand, and find the right information for each specific patient. So today we have the electronic health record that is a huge repository of patient data. And it has both structured field, discrete fields, as well as lots of clinical notes, lab reports. So in order to improve personalization care for patients, we need to be able to take both of those types of information and essentially go through them to find the right criterias that are met for each patient. Now, things can include finding care gaps within the patient's charts. So if in your previous visits your physician said, "Hey, come back in 6 months, and we need to do your mammogram," right? Our machine now can go through that and be able to pick these up without having a team of humans reading through them constantly to find these care gaps that need to be taken care of. We can also look at identifying conditions within the patient's charts for things like HCC suspecting. So if you have comorbidities or conditions in the past that hasn't been coded up, that may impact your care with your physician. So AI can now very efficiently read through thousands and thousands of pages of charts, find the right evidence, and surface that up for a physician to determine, okay, yeah, this has been missed. I should code that up in the system. Now, apart from clinical use cases, there can be kind of recommendations of care that helps with patients accessing care, such as offering ancillary services or transportation. If we've seen in your history that you have trouble making it to the hospital, maybe we can recommend transportation services to help you get to your services. So yeah, really wide range of applications here.
Great, that's very exciting. And so it sounds like we can take the entire corpus of data in the EHR about a patient, the portion that's structured that we've always had access to, but now this vast portion that's unstructured, feed it through large language models to sort of understand that unstructured data and make sense of it. Now we have a comprehensive understanding of who the patient is, what their needs are, and hence we can better serve the patient with personalized recommendations, whether that is being overdue for care or a missed care opportunity, or something that is more administrative or logistical in nature, like transportation that the patient may be lacking access to food or housing or any other social determinants, or even a clinical trial where we now have enough knowledge about the patient to know if we can match them to a trial that is currently enrolling at that particular site. So that is all very exciting, and it sounds like has been unlocked with this new AI capability in large language models. I want to switch gears a little bit and now talk about the flip side of that, which is, are there any use cases in healthcare that you believe AI is not well suited for yet, and areas where we should be more cautious of deploying AI right away?
Right. I mean, certainly there are many ways to misuse this very powerful tool. After all, it is a tool. It's not a full kind of general intelligence. And AI is only as good as the data that you feed it, whether it's in training or in the prediction itself. So for areas that might affect patient safety, such as diagnosis or predicting outcomes, treatment recommendations, these are very highly important care points where we should certainly involve human experts in reviewing the outputs of the AI system to guard against unexpected results, because humans still have broader context on the holistic environment and about the patient. So generally, the AI systems today have limited context or knowledge that are specific to individuals or patients. You have to find this information and give it to the AI specifically. Now, it's still a very narrow piece of information. So if it's not able to take the whole situation into account, it will give you unreasonable results as judged by a human. So those are areas that I think we need to be particularly careful about.
Great. And you mentioned some areas like the diagnosis and treatment where we can sometimes involve humans sort of in the process to sort of guide and direct the AI or sort of leverage the AI when helpful. Would love to hear more about that, and if there are examples of that being done today or use cases where you see AI sort of coexisting with humans and sort of delivering a better standard of care.
Yeah, the best use case that I've seen so far is in identifying conditions or suspecting prior conditions from the patients. Like I mentioned, it's very time consuming to read a ton of text information day in, day out. And so the AI is very good at finding information, and it can also do some reasoning on top of that. So it can, answer questions like, does this evidence or does this, patient's history support whether he has atherosclerosis or not? And it can give an assessment. Now, we need to have the human kind of look at the final response to see whether it actually makes sense, make sure there's no errors in the data. So that saves a lot of time from the physician and the staff perspective, and not having to read the entire thing. They can just look at the evidence on why the AI has picked this particular output and just make a determination very quickly. So that's one example. You can certainly think of others, such as, these days providers are inundated with messages from patients, and it's certainly very difficult to get to them all in a very patient and empathetic way all the time. So you can have AI kind of draft up a message based on kind of past conversation history or kind of similar queries from other patients, and that would be an opportunity to allow the provider to better engage with the patients by not having to type repetitive responses to thousands of patients.
Great. I think those are all very valuable use cases. I want to maybe move a step further. And so let's say there's a healthcare system that wants to implement one of these applications of AI in healthcare. What are some challenges that systems may encounter when implementing AI-based technology, whether it's on the administrative or clinical side of their organization? And how can some of those challenges be mitigated?
Right. I mean, so far we've talked about the AI models themselves, the core intelligence that's at the core of these breakthroughs. But when you try to put it into real world systems when implementing these, it actually involves a complex system of engineering pieces. So it's not just the AI model itself. You need some sort of user interaction layer, like a front end. You need databases or vector databases to store the information that the AI needs to process and retrieve as it's needed. You need workflow coordination systems. So if you have, 1,000 appointments this week, which patients do you process first, when? So you get the most up-to-date data. You may need to reach out to the patient for some information prior to you running your AI model. So this involves a lot of coordination and automation at scale, and to deliver a delightful experience for the patient and staff. It's really a extremely challenging piece of engineering to build and implement. So that's number one. And then other challenges are specifically data security and privacy preservation. Now, AI requires large amounts of data to be processed and moved around, right? If you have data just sitting in a silo, static, it's not going to, give you the value that it has, right? So you have to move it around, and in moving big pieces of data around, you have to be very aware of, if that data is secure and the permissioning around that. And finally, output robustness and repeatability. So, just in our experience in working with AI, sometimes it feels amazing that it's doing, magical things that you wouldn't necessarily expect it to perform. But other times you get really frustrated that it's just not doing what you expect. So, repeatability is really important. So that comes down to having the infrastructure to do evaluation and testing for the efficacy of the model. When you make changes, make sure it's not regressing. So those are kind of challenges that we think about all the time.
So those challenges are really illuminating to hear about, especially the ones around sort of the number of engineering pieces and sort of complexity that needs to come together to enable this, which sort of leads me to my next question, which is, how should health systems think about when they should try to tackle and build some of these AI applications in-house versus partnering with an organization that specializes in sort of developing these technologies?
Yeah, so this comes down to obviously the technical capability of the health system and the type of problem that they're trying to tackle. I think AI is an area where it's worth experimenting and learning by doing it directly. So that's the best way to understand its capabilities and limitations. So there may be small areas of focus where it maybe makes sense for health system to try if there are existing tools out there that you can integrate quickly. Those are kind of great as to get up the learning curve. Now, for broader automation and kind of end-to-end workflows that will truly drive value and ROI for the health system, that's where it could make sense to partner up with specific organizations that have experience in doing these kind of large-scale automation safely and securely, while making sure that staff, patients are all delighted in that ecosystem. So yeah, that's kind of how I see a health system may be able to leverage internal and external resources.
And with health systems, it seems like enterprises across all industries are rushing to take advantage of AI within their operations and products. Healthcare is unique given sort of the added dimension and nature of patient safety, both in terms of course, actual safety, but even in terms of the security of the data, like you mentioned. How can we better enable and ensure the safety and quality of AI in healthcare, given that this AI may eventually be used to guide decision-making and sort of clinical outcomes?
Mm-hmm. Yeah, so probably the first thing I can say is that it's really important to understand, again, the capability and limitations of the AI. Because the systems are so powerful today, sometimes it's easy to be, lulled into a state of like thinking that it's better than it is. But a lot of times it fails unexpectedly. So by focusing on the edge cases and potential cases that it can fail, I think that's a way to improve patient safety and security. So that's number one. Number two is we're just in the beginning of this technology. And so there's a lot in terms of learning how to feed it the right data so that it's not making things up when it doesn't have the knowledge. And also, just systems around guardrails. So we spend a lot of time putting in guardrails in the sense that whatever the output it comes from the AI, we need to have ways to validate them, whether at the basic level. So if we're extracting a phone number, it should have a certain format. And so in terms of things like entity extraction, we need to reaffirm that whatever is extracted actually comes from the text that I care about. So there are these layers that you can build on top to validate the outputs of the model to make sure it's not generating something garbage. So yeah, those are pieces that kind of are actively working out to ensure patient safety.
Yeah, wonderful, and certainly very important. I want to switch gears in our last few minutes to talk more about maybe the future landscape of AI. To start with, as we look ahead to the future, where do you see the potential of AI to transform how care is delivered and experienced for both staff, providers, and patients? And would love if you could share any use cases of where this may be already, in use today.
Right. So, yeah, maybe in the next few years. I mean, we'll see how long this takes. A lot of the transformation, I think, will be happening in the patient care journey, in the sense that you can now have AI assistants that can almost serve as a personal assistant to the patients. It knows the health system's operating procedures, hours of operation, who to call, who to talk to if you have a certain complaint, and it even has access to patient personal information and clinical data to see your medical history. So you can have an assistant that is essentially allows the patient to converse with them directly. If you have a knee pain, how do I schedule with your orthopedics or specialists? You wouldn't have to have call centers, putting people on wait for minutes at a time, and yeah, people can get the answer they need right away. So that's on the kind of the patient access and patient experience side. On the back end of the processing, there are just tons of opportunities in having valuable insights from the clinical documentation and progress notes and reports, where you can do care gap chart scrubbing, you can do clinical trials matching. So these are all use cases, and some of them we have implemented and productionized at Notable. So yeah, those both in the front end of interacting with patients, and then reducing staff burden in having to review charts is, I think, what will be transformational in the next few years.
That's very exciting. And so it sounds like we can almost introduce an entirely new way for patients to interface with their healthcare system through a more conversational, personalized experience on the web or mobile or any other interface. But you're suggesting, in addition to that, not only is it a better interface and experience to engage with, we can actually then personalize opportunities and care for them in a way that we couldn't do before. And that unlocks a whole array of opportunities for patients, but also greatly improves the experience for staff who previously may be spending, several hours a day reading the medical record and now don't have to. So it feels like this is a unique sort of win in that it aligns the interests of patients, providers, and staff all together and sort of creates a better experience for all parties.
Absolutely. Yeah.
So I want to fast forward even a little more now and talk more about maybe the next 5 to 10 years. I mean, it is hard to imagine, given how much progress there's been in just the last 12 months, what the world could even look like in 5 to 10 years. But would love to get your perspective on how you expect the state of healthcare to evolve in that time frame, and what do you hypothesize we'll be using AI for in the next decade?
Mm-hmm. Yeah, certainly the last 8 to 10 months has been a whirlwind in the AI realm, and it's very difficult to predict how things will progress. If the speed of progress will increase, in which case it's very hard to see where we will land. But from what I've seen, just looking at the landscape, there's just a ton of investments, and companies, whether big or small, they're all kind of full steam ahead in implementing and experimenting with this technology. So with these market forces at play, I think very quickly, we can see just competition and bringing in the best solutions to the market. So, with better transparency and capabilities. So I think that's a huge positive, just the amount of interest and people experimenting on ways that we can use this technology to good effect. Now, through that process, we'll also learn the effects and things that we need to be aware of in terms of data and patient safety and the risks. So, there's a big debate on whether AI should be closed system where, highly trained and large companies develop them, or we have it more out in the open, the so-called like open sourced code and open source development. Now, I think both have merits, but we will see, just much better kind of ways to guide the AI and, give it the right information such that it better aligns with what we want it to do. Like sometimes when you interact with these AI systems, you feel a little bit frustrated because it's just not doing what you want. And so I think in the next 5 to 10 years, we'll have a much better understanding of how to control and really put guardrails around these AI to do exactly what we desire. And that's what will unlock a lot of healthcare applications, because we have very strict guidelines and specificity on what needs to be done under what condition. So having that knob, I think will come very soon.
Yeah, on that last point, it's interesting. Maybe 20 years ago, there was this idea that we need to start teaching statistics to clinicians because in medical school or training, because so much of interpreting clinical trials was knowing how to interpret sort of statistical results of these studies. And then 10 years ago, it was about, hey, maybe we need to train, future clinicians on computer science, because interacting with the EHR and developing applications is such a core part of the day-to-day job. And it feels like maybe in the next decade, actually training on how to work alongside AI agents and sort of understand weaknesses, flaws, the best way to leverage them, the best way to understand reproducibility and explainability is going to be key. So certainly a big change on the education side as well, like you mentioned. So we are coming up on time. So maybe as a final question, would love to hear if there's any final pieces of advice you would share with our audience today on embarking on the AI journey, and anything else to keep in mind as we kind of usher in this new paradigm of intelligence in healthcare.
Yeah. It's I would say a couple of things. First is just be bold, but start small, because this is new technology and people are still coming up to speed on what it does, what are the potential downsides of it. But do experiment with it, because of the 10 years that I've been working in data science and machine learning and AI, this is the biggest improvement in capability and generalizability that I've seen. So many things have been unlocked by this technology, and I'm sure that everybody can find some way to leverage it. Now, just internally, we've seen a 10x implementation speed of certain workflow automation, specifically dealing with text data, versus the state of the art even a year ago that we were working with. So this technology is incredibly powerful, and it's worth a little bit of investment to learn what it can do for you. And the last thing I'll mention, which I haven't talked about at all in this chat so far, is actually user experience design is even more important now in this new AI interface. Traditional designs are all based around the user interface, right? Graphical interfaces, buttons that people click. But humans naturally use language to communicate and is very expressive with it. So I would say, think deeply about what's the right interaction in this new kind of AI paradigm. And I think this one will kind of make or break the success of your healthcare application.
Fantastic. Well, thank you so much, Kevin, for that piece of advice. as well as just sharing your knowledge overall on the space. The space is moving very quickly, and to have an expert like you join us is always incredible. So thank you so much.
Yeah, it's been a pleasure. Thank you.
So what we'll do now is transition to sharing for a few minutes a high-level look at the Notable intelligent automation platform. We'll cover, again, at a high level, how we've architected the platform to be able to automate hundreds of workflows on behalf of our health care system and health plan partners, and how we've enabled over 1 million automations a day on the platform so far. So this is a high-level look at the Notable platform. There are 3 sections to it, as you see. And so on the far left, we have integration, then we have intelligence, and finally is action. And you can think of this as sort of the 3 key domains you need to enable a digital assistant to perform workflows in place of humans or in a way that augments humans, right? So the digital assistant needs a way to integrate into the systems that humans are using today to pull data and to write data back. Next, they need an intelligence layer, a way for them to be able to make decisions on all of the data they're pulling in and suggest a recommended action or next step. And then finally, you have action, which is once they've made a decision on what needs to be done, the digital assistant needs to have the ability to actually act on it and carry out that function, right? So this is why we've displayed the model in this way. The integration is getting the data, the intelligence is making a decision based on it, and the action is actually carrying out the decision that has been made. So on the integration side, Notable integrates with all types of data and source systems to enable the digital assistants to have access to all of the data they need to make the best decision. So this includes integrating into source systems like your electronic health record, practice management, CRM systems, and more. We also then integrate with third-party systems like payer portals, SDOH or claims data, and even consumer and third-party data that can inform us more about who the patient is and how we can better serve them. And then finally, we integrate with any number of partners in our ecosystem or in your ecosystem that can help us better serve patients. So with this robust multi-source integration, we're able to ingest data across all of your data silos, whether that's in the EHR, a payer portal, or a third-party partner. And once we have all of that data, we feed it through our intelligence engine, which we call Patient AI. So Patient AI is the name for Notable's entire intelligence suite. This includes everything from optical character recognition models and computer vision to much of what we touched on today around large language models and the ability to perform natural language understanding and generation. So we take all of the data we have on a patient, we feed it through Patient AI, which essentially takes that data and makes sense of it to create a very accurate representation of that patient's needs. So it understands, is the insurance card active or has it changed? What is this patient's propensity to pay and what payment method are they most apt for? What's the patient's likelihood to no-show to an appointment and how can we get ahead of that? And also goes into clinical factors like understanding every one of their prior care appointments. What are their upcoming care needs? How can we better service them? And as we talked about, even items such as, are they a match for a particular chronic disease management program that you may have in place? Or is this a patient a match for a clinical trial that is currently enrolling at the particular site? So all of those decisions and analysis is done within the intelligence section. And then we move into action. And so, as I mentioned, Notable today automates hundreds of workflows across 5 core domains, which is registration and intake, authorizations, scheduling, population health, and referrals. Within each of these categories, there are many, many workflows that are being done by humans today. And what we've seen be really encouraging is that this type of platform can enable digital assistants to perform these workflows in a very accurate and efficient manner, and often with fewer errors than humans are making today, all while dramatically improving the experience for patients. On the next slide, we'll dive into this a little deeper and give you a more tangible example of how this comes to be. So let's take the example of a patient, we can call her Shelby, who is overdue for breast cancer screening, often done through a screening mammography. So how Notable approaches a problem like this is we first look for all unstructured and structured data about this patient. Now, the structured data is pretty straightforward. If the EMR has already structured this information, we can simply ingest it, analyze it, and determine if a care gap exists. But as we discussed, the vast majority of data in the EHR is unstructured. So Notable will pull all of that data in, it'll apply a computer vision model to turn those images or prior mammogram reports into text. It'll then feed all of that text into our large language model based applications, which can take that data. It can read through every single one of Shelby's prior mammograms. It can read through every one of her primary care, clinic notes, and even any other clinic notes that have been documented in the last several years. So in essence, reading hundreds of clinical documents. It can then extract the most important insights from those documents. So for example, if it finds a mammogram from 2 years ago, it can read through the text, extract the date that the study was performed, when it was read, what the impression was, what the follow-up recommendation is. And it can do that not just for one mammogram, but again, across hundreds of clinical documents in the EHR. And from that, it can develop an understanding of the patient and also a recommendation for whether or not this patient is due for another mammogram. And so we see this being incredibly valuable. Often in 7 to 12% of cases, it's the unstructured data that leads us to a new understanding of whether this patient actually has a care gap or not. Also very impactful for items like colon cancer screening, where the recommendation is to do it every 10 years, but the last colonoscopy may have been abnormal and you actually need a 5-year follow-up. That isn't often captured in structured data, but using an approach like this, bolstered by large language models, we can read that prior colonoscopy report, identify that the recommendation was a 5-year follow-up, and then using our engagement capabilities, Notable can automatically reach out to the patient, let them know they're due, and enable digital self-scheduling so the patient can schedule that visit automatically without any staff involvement needing to be present. So that is just one example of patient AI in action. Again, we're leveraging this across administrative, clinical, and revenue cycle functions to help ensure that we are allowing staff to practice at top of license, reducing errors for the health system, and also improving the patient experience. So hopefully that is a helpful look at the Notable platform. And thank you all again for joining us today for the Fireside Chat with Dr. Kevin Huang and a high-level look at the Notable platform.
Wonderful. Thank you both so much. We appreciate you sharing your time and insights with us today. And we also want to thank Notable for sponsoring today's content. And to our audience, thank you for joining us as well. Please take a moment to fill out the post-webinar survey on your console and have a wonderful rest of your day.